Pipe it up. Alright. So my last videos was dead. This one's not gonna be as dead. Alright, we're gonna talk about SOHCAHTOA. I remind you about SOHCAHTOA, right? SOHCAHTOA. S, sine. Opposite over hypotenuse. C, cosine. Right? Adjacent over hypotenuse. And then tangent opposite over adjacent. This is all relative to a right triangle. If we're looking at this angle here, the opposite side of this angle is the side that is furthest away from the angle. That's O. The side connected to this angle is the adjacent, and the hypotenuse is always the longest side. It's the side furthest away from the 90 degrees. Alright? Y'all good so far? You a little better?
You couldn't tell me that over there though.
I couldn't tell you that over there?
No,
I didn't think you needed that part.
That's what I needed.
Oh, okay, you got it now.
Yeah.
Alright, let's do a problem. So give me some.
Okay.
Alright, so we got a right triangle.
So it goes 8, 15, and 17, like on the lines.
So I assume this is 17.
Yeah.
What's this?
15.
Hold on, what
15?
Oh.
And 8?
Yeah.
No,
Alright.
8 is the problem.
No, I got the 8. I solved it already. It's 8.
Well, I need to have you solve it.
Alright, so
It's 8. I solved it already.
now what you need to find the angles?
Yeah.
You need to solve the whole triangle.
Yeah, I did that.
When you solve the whole triangle, you need to find the measure of the angles. You need to find the measure of the angles and all the sides. First things first, whenever you're given like two sides, you just use Pythagorean theorem to find the other side, right?
It's 8, not what I said.
Okay, we're gonna get there. You need the angles, right?
Yeah.
Alright, cool, we got you. Alright, so what you said this is 17 squared is like 289, right?
Yeah, 289. And then
289
15 is
equals 225
plus x squared.
plus x squared. You subtract this, x squared equals what?
40. Yeah, 40. No, 64.
Right, 64. So then this is 8. So you got that side, right? Now we need to find, let's get that x, we're gonna find this, make this y. Okay? Now, whenever you're trying to solve for the triangle, you find x and y, we can use any of these ratios to figure it out. So let's use, we're finding x. What do you want to use? Sine, cosine, tangent?
So sine.
Sine. Alright, so sine of x equals opposite over hypotenuse, right? Because we're trying to find the measure of this angle, Lexi, we have to do inverse.
That's what I need to. I know.
You good now? So you would do inverse sine of 15 over 17 to find the measure of the angle. Okay?
Oh, that's all we need to do?
Yeah, because essentially you're solving for x, right? In order to solve x, you gotta get rid of this sine. And so you divide by 1. This is sine, this is 1 over sine. So when you're trying to find that would be inverse sine of what sine would be. Okay? And then so to find y, you could do the same thing. If you do sine, you can say inverse sine of y being 8 over 17. Right? For y, opposite over hypotenuse is these two. Right? So you do inverse sine of that. That's for y. This gives you y. This gives you x. Okay? So when you try to find a measure of angles, you use inverse sine, inverse cosine, inverse tangent. Okay? Y'all good? Yeah, what's up? Which with what? Alright, well, first things first. First thing first, set up your ratio, right? This is the first thing you want to do, right? We knew that we were trying to find this one, right? And we decided to use sine. So in order to use sine, based on this is the opposite side of this sine, of this angle, and this is the hypotenuse side of this angle. So remember, sine is opposite over hypotenuse, so y, right? And so now from here we solve for x. So we kept x there. So x is going to equal the inverse sine of this ratio. That's it. Okay? Let's do another one. Do you need to do another one? Are we good?
No, we good.
Y'all good? Number 1? All right, now number one was, let's look at number 1. What does it say?
It says A, find A.
Find A.
And this A, 16, 34.
34. Right. So this is a right triangle. We're trying to find one side. We're given two sides. We use a squared plus b squared equals c squared. Yeah, you expect that. You good with that? Okay, cool. We good. Everybody happy now?
Yeah.
What's up?
I don't know. I don't.
Do number 4.
I thought we did something.
I think I know what I'm doing.
Requires the inverse. We did sine and cosine and stuff without the inverse.
That's when you're trying to find. So if I was given one side and I was given an angle and I was needing to find the other two sides,
Okay.
then you would use just regular sine
Okay, makes sense.
of the angle. You good? Huh? All right, that was actually number 4. Let's do number 4. All right, number 4. What's the triangle look like?
A right triangle.
Of course it does. Oh, see, number 4 is a 45, 45, 90 degree
So
triangle.
is it 3 root 2?
Yeah.
Yeah. I think so. Yeah, it is. All right,
Yeah.
so 45, 45, 90. There's 2 ways to do this, right? If you want to use the sine, cosine, tangent, we can, right? So we're trying to find this piece, and we got this. Based on this 45, we could say what? It's adjacent, opposite, and hypotenuse. We're going to use sine. So this would be adjacent hypotenuse is cosine. So we can say cosine 45 equals adjacent E over hypotenuse 6. Right? So then the measure of E would be 6 times the cosine of 45. Right? That's E. Right? Another way to look at this is basically 45, 45, 90 degree triangles. That's x root 2. Kiara. Alright? So x root 2. The 6 is on the x root 2 side. So to solve for x, solve for these parts, you can divide everything by the square root of 2. So you're going to have 6 over root 2 equals x. You can't have the root 2 there, so you multiply top and bottom by root 2 again, right? Root 2 times root 2 is root 4, which is 2. And so you end up with 6 root 2 over 2, which reduces to be 3 root 2.
Oh, I did not do all that.
You did, though.
No,
You
I
just didn't write it all out.
I just said 3 plus 3 equals 6. So that's.
Oh, nah, this is the math to it. Alright?
I never did the math. And if it's 10, I say 5 plus 5 equals 10. Add a root 2 on it. I ain't never like do the math.
Okay.
Does that always work?
Mostly, yeah.
Maybe if it's all even, though. I mean, if
Yeah,
it's even.
yeah.
Yeah. Alright, we better now?
Yeah.
Alright, cool. Let's do the math.